Our presentation is Moving Architecture Animated Maze, the Intertextuality between Player and Environment Agents. I'm Yiou, an architect, game designer, and researcher from Harvard Graduate School of Design.
I'm Yujie, and I'm an interaction designer and creative technologist from MIT.
The excessive nature of the historical maze gave us our initial idea. Maze introduced choice and indeterminacy. The maze belongs to the Ilinx, theorized by Yujie, which is based on player navigation in disorientation. In modern game classification, the game maps onto the puzzle genre, which activates problem-solving skills based on logic and spatial cognition. The basic geometry of the maze is a sprawling horizontal structure of orthogonal walls that generates a space of possibility. On the micro level, the maze contains a multitude of this single unit rotated in different orientations. On the meso level, the maze is semiotic. The units cluster together through various combinations and permutations, forming these four types: the corner, the passage, the junction, and the dead end. On the macro level, the maze is generated and continuously generating space of possibilities from propagation and rotation. Games are anchored on rules. We want to design a game that is able to operate itself once rules are established. The novel rule that separates this game from the rest of maze games is based on alternative feedback mechanics. After every move the player takes, the maze reconfigures in response to the player's movement. Space evokes and constructs a narrative, offering indexical narrative elements that provide spatial comprehension for the player. Instead of explicit instructions that tell the player how to move forward, the game opts for having the player discover the pattern through indices and learn to navigate the moving maze with a difficulty progression from easy to hard.
In the game, there are two agents, the player and the environment agent, which is the maze. On the superficial level, the player aims to navigate out of the maze, while the maze reconfigures to obstruct the player from finding the solution path. The oppositional goals create a zero-sum situation of the player playing against the maze. But unlike AlphaGo that is built to win, the ultimate goal of the moving maze as a video game is to immerse the human player in an engaging, rich game experience rather than defeat the human player. The environment agent would simultaneously obstruct the human player and mitigate this action to match the level of the player to enable them a successful exit most of the time, but remain challenging to them with the probability to let them fail. Therefore, the moving maze is not just a human-machine zero-sum game, but also a non-zero-sum game, whose game mechanics is explicitly adversarial but implicitly cooperative. To program the maze that adapts to the level of the player, a set of game state parameters are defined to determine the difficulty for a player to get out of the moving maze. Player-dependent parameters also factor into the quantification of the game to evaluate the player experience. We propose that difficulty index of a solution path is a weighted sum of game state parameters mentioned above. A smooth difficulty progression is quantified as an incremental increase of difficulty index while leveling up. It is also important to notice that these game state parameters are interdependent. To better approximate the weight of each parameter, playtest data through inverse reinforcement learning at a statistically meaningful scale are needed. To evaluate playability and player engagement, we conducted preliminary desktop playtests with 5 players. The results are shown below, which achieved our initial goal in difficulty progression. The concept of a maze as a gameable architecture arises from its spatial potential to engender modes of play, measured on player engagement, which involves game mechanics, and balanced player agency and environment agency. Game balance is the fine-tuning of the game to be engaging, moderately challenging, and often manageable with incremental raise in difficulty. Game balancing is often a time-consuming process, and new learning algorithms have recently been used to make this process more efficient. In our initial moving maze game prototype, we propose to introduce adversarial reinforcement learning in this multi-agent environment to improve competitive game mechanics.
Thank you for listening. The moving maze is playable at itch, and our team is working on developing the game onto the next level, so stay tuned.